learning. Uh, there are different versions of this terminology. So there are terminologies which say that business analytics, then there is data analytics, then there is uh, data science, and there is data engineering. So these are four terminologies that are typically used interchangeably in the industry, but fundamentally they're a little different. So any idea about what is the difference between business analytics, data, if at all any, data analytics, data science, and data engineering? These are the four main pillars, if you see, of the entire the gamut of machine-driven decision making, if I may say so. Okay. And today there's one more, these days, one more pillar that is added, which is generative AI. So you can say that these are the five pillars. So how do you differentiate them? Any idea before I get into details of this? How do you differentiate business analytics with uh, data analytics, with data science, and with uh, data engineering?
Sir,
And
I believe
yeah, yes, please go ahead, Makrant.
yeah. So basically the difference uh, business analytics and data analytics, I believe in line that is used for optimization per se in terms of suppose designing for engineering
Mhm.
perspective, and
Yeah.
business analytics can be used for business purpose.
Okay. 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 Any example you can think of?
So business analytics can be used in such a way, sentiment analysis. Suppose if we
Okay.
want to see how our product is behaving in market, what are people thinking of it, so we can do analysis of that thing using
Mhm.
business analytics. But if
Okay.
we want to suppose design a part, if
Mhm.
it is having some specific physical property and which some inherent properties will come out, so for that engineering purpose and engineering kind of, we use the term data analytics.
Okay. 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 And data science and data engineering.
So what was the question? If you can repeat that
Yeah. Yeah.
one.
No. No. Sure. Sure. So I was. I mean. I was just talking about that we will have an idea about these components, and one of the components, of course, is analytics, which is a key component of digital transformation. And then I was mentioning that there are different terms that are used in the industry and made very often they're used interchangeably. For example, business analytics, data analytics, data science, data engineering, and these days we're talking about Gen AI or generative AI. So many times they're used interchangeably. So I was just trying to figure out if we understand the difference, if at all there is any difference, or they're just different terms used in, as per people's convenience, or there are any difference between these terms.
Okay.
So
So
according to
the
me, I think data science is basically, or the scientists which are there,
Mhm.
they are basically
Mhm.
like the innovators. Whatever new things are being developed using all
Mhm.
the latest digital techniques, they are the ones who are
Mhm.
utilizing them, be it AI, be
Okay.
it machine learning. So they are the
Mhm.
ones who are doing, while engineering is more in kind of wherein they build some platforms, etc., and then
Mhm.
maybe it is like you can call all the e-commerce side something also like data
Mhm.
engineering. While
Okay.
data analysis was what we call is getting the data from the system and then analyzing it for the betterment of the company to improve the
Mhm.
sales,
Okay.
forecasting, etc. This is what
Okay.
I think.
Mhm.
So
Okay.
Sir,
Okay. No.
in my opinion, data science is a much bigger umbrella, and within
Okay.
that there is data engineering and data analytics. So
Okay.
Yeah, so data science is when we talk of it, it actually covers the mathematical part of the overall algorithm generation
Mhm.
and the how
Mhm.
to view the data, how to
Right.
make sense out
Mhm.
of data. It covers everything.
Okay.
And when it comes to data engineering, it is more related to the lower level data engineering, as in how to put it in a polished way so that some sense can be made out of it using some well established algorithms. And
Okay.
analytics part is how we make use of those algorithms and really get the insight out of it.
Okay. 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 Yeah. No, I think that's fair. I mean, I mean, honestly, there is no literature that clearly defines differences as such, but people, kind of interpret it differently in different contexts. Now, this is my view. Uh, Business analytics is essentially interpreting a data. So suppose I give you just a sales data. In fact, we'll do a small, I would say a caselet. Okay, I'll just give you a caselet right now. It's very simple data. Let's say sales data of an e-commerce company. Uh, and so here there is no, machine learning as such, no, any sophisticated technology involved. Maybe just an Excel sheet of just a sales data. And we'll see that there is a lot of insight that is hidden inside the data. The ability to bring out those insight, and hopefully every time I've done this exercise, the results have come out well, in the sense that actually I've seen that some have got the insight, some have missed the insight. So it comes out very clearly that even if same data, all of us are seeing the same data, probably all of us are not able to bring out the insights from that data. Okay. And it depends on various factors. For example, it depends on your domain knowledge, it depends on your general business knowledge, depends on your analytical ability to think. So it is no, here we are not talking about any sophisticated algorithm or anything like that. It is just interpreting the data. And this has been there. Honestly, it's not something new. It has been, that's what most managers do. Okay, they are given a report and they analyze, they find out what is going wrong, and from there some of them have uncanny ability to ask the right questions. So that's entire business analytics. Data analytics is essentially how to generate those kind of reports, so especially from visualization perspective. So there are people who are very good at using tools like Power BI or Tableau. These are data visualization tools, and usually when you get the data, those of you are from IT, you know that the data is in a very raw form. Let's say I get the data from an ERP system. Data can be in a very raw form. Okay, I need to um, process this data before I can make any meaning out of it. Okay. So these data analytics guys, they are actually the people who are building those reports. Okay. Again, they're not building any models or any algorithms on that, but they're just processing the data and building charts and visualization of that. So that is the data analytics part of it. Data science, on the other hand, as some of you said, is a science part of it. Science means here it is, you're talking about the various machine learning models. So here you need the knowledge of statistics, uh, algorithms, which helps you to typically do a predictive analytics or a prescriptive analytics. So there you need coding knowledge. These days, of course, there are a lot of no code platforms that has come in, like Nime. Will let's see if we type permits, we'll try our hand in Nime, which even if you're not a coder, you can actually build simple machine learning models on that. So that's the data science part of it. Data engineering is moment it comes to large volumes of data, you have to work on various types of data. For example, very large data sets, big data, streaming data coming from machines. So Makrand works in Maruti. So if I have to predict, for example, whether a machine is going to fail or not based on certain parameters of the machine, like a temperature or vibration or sound, etc., which is not physics-based. So there's a difference between a physics-based model and data-driven model. So physics-based model is you have a formula. You know if the vibration goes beyond this point, then the machine is going to break. Okay, so there are certain limits. So based on that, you decide. So that's a physics-based model. But what happens is that when there's a machine in an environment, there are many other factors. Okay, maybe the ambient temperature, maybe moisture, humidity, the skills of the worker. There are so many factors which it's not no, it's not possible to draw immediate correlation and put it into a formula. Okay, and that is where the data-driven model comes in, where essentially I'm saying that I do not know the formula when the machine is going to break. Okay, but I do have past data of various attributes, and I also have the data that when the machine has failed and when the machine has not failed. And I'm asking the model to find out that relationship. That relationship is not physics-based, that relationship is data-based. Okay, and that's a realm of analytics, data science. Okay. And this data science can be used in various aspects. Still, very recently, it was used more in the customer facing aspects, like it's an e-commerce company predicting a customer churn, or a telecom company predicting a customer churn. Somebody mentioned about sentiment analysis, like the various reviews and all the text. I can extract the information from the text and say to what extent people are saying positively about a product, and whether people are saying negatively about the product. So those are all customer facing. Of late, with Industry 4.0, this data science has got into providing useful inputs for running the factory. So today we are talking about things like digital twin, okay, which is basically a digital replica of the factory, and you have a two-way data exchange. Okay, so actually you can theoretically control a factory from your laptop. Okay, so those kind of things are now coming. Also, that's the science part of it. And then how do you implement that using cloud environment? There's something called edge computing. So there's a lot of engineering part of it. Okay, so that's the data engineering. And Gen AI, of course, we are talking today of, where we can create, okay, use machines to create things. For example, I can at a very simple stage, I can automate writing of mails. Okay, at a more sophisticated level, I can have, let's say, a robotic process automation based on Gen AI. Okay. Chatbots. Okay, these are examples. So these are the basic differences. Okay. Yeah. So any thoughts, questions on that? Great. So what I'm going to do, I'm uploading a particular, I'll say a case late, okay, in the Teams, and it has a Excel sheet also. Okay. If you can download that and just take 15-20 minutes to go through it. Okay. And there are two questions in the caselet. And there is a very simple data Excel file. Okay. So you may want to see some patterns in the data, etc. from that. And just try and see if you can answer the two questions that I have given. Just give me a second. Okay. I've just posted it in the Teams. See if you can download this. There are two files, one a PDF document and the other is an Excel file. I just also open the PDF document, that in case you find any difficulty to download, you can just read through it. Have you got it? Can you just confirm that they got this?
Is it on the Teams?
Yes,
Yeah,
yes, sir.
I've just
downloaded.
uploaded the Teams.
Okay, okay.
Yeah, it is there on the Teams file, that folder.
Yeah, I just now after.
There's a PDF and an Excel sheet, right, sir?
Yeah, there's a PDF and Excel sheet. Yeah. So this is the PDF. Just take 10-15 minutes to just go through it and So the two questions here are very simple. What is going wrong? And of course, what should Shweta do to turn the situation around?
Sir, I've gone through the case, but I have my office meeting and
Okay.
so I have to drop off. Sorry for that. But
Okay.
I will listen to the recordings later on.
Okay.
Maybe
Okay.
after 45 minutes, once my meeting is done, I will join back.
Okay.
If,
Okay. Fine.
it's
Fine.
that
No,
way.
no, no, no problem. No problem.
Okay, thanks a lot.
Okay. Yeah. Okay. What about
So
others?
So from the
Yes,
data, I
Avinath?
can see this is more of a cyclic behavior of the
Okay.
number of orders.
Okay.
There is a repeated pattern of getting crest and drops the data.
Okay. That
This
is
is what
right.
I could yeah that
Yeah.
and I believe it is again following the same pattern as the previous company of the Shweta Trehan. Big Buy
Uh,
had a cyclic demand, like weekends they had a very high demand, and on the weekdays the demand was low.
Okay,
It-
so
it-
so in this particular case, where is the demand higher? Is it, did you see a pattern in that? So let me just open the spreadsheet.
During the week, if I mean, I'm not sure whether I can say that directly, whether because I don't know where the weekends and weekdays are lying, but
The
it
dates
seems,
are there. So the
yeah,
dates are there. So can you
I
figure
need to
out from the
just a second,
dates?
sir. 5th of Feb 2022. Let me check. I'll
Yeah,
have to check the year first.
yeah, I understand. Yeah. So what you're saying is that if we just plot this, a simple
2022, 5th of
line chart.
Feb. Yeah. The
So
5th of Feb is actually week end. So it shows a different or completely different viewpoint, because in this case the
yeah,
orders
this
are
is
low on weekends and high on weekdays.
yes. So um, first of all, you are right. And as I was saying that this is where, that data-driven mindset is important, where I should be able to see this pattern. And not only that, I should be able to see the fact that in this particular case, there are less number of orders in the weekends and more number of orders in the middle of the week. So if you look at the specific dates, okay, you will see that on 8th January or 15 January, these are the weekends. Whereas if you look at the peak, let's say 12th January or 5th January, these are the middle of the week, Wednesdays or Thursdays. Now, this is not something normal for a typical brick and mortar retail industry. If you notice that Shweta comes from a brick and mortar retail industry. So if Shweta was not careful about analyzing this data, it is very normal that Shweta also would have assumed that there'll be more demand during the weekends where and less demand in the middle of the week, which typically happens in any normal brick and mortar retail. And she would have mobilized all her resources, whether it's inventory, whether it's the delivery machinery, because the e-commerce side, so the entire last mile delivery is a very important resource. Okay. According to her previous perception that there'll be more demand in the weekends and there'll be less demand in the weekdays. And as a result, what would have happened is that in the weekends, where the demand was less, she would have had excess resources. That means the inventory cost, carrying cost will go up because she will have excess inventory during those days. On the other hand, the middle of the week where typically she would have planned for lower amount of resources, lesser amount of resources, those days there'll be a resource constraint, whether it's inventory, so there might be a lost sale or a delayed delivery. And that's the reason why you see customers are complaining about delayed delivery. Some orders are also getting cancelled. Not only that, there'll be an extra stress on the workforce, because the workforce, you have in the middle of the week, you have planned for less amount of workforce, and this less workforce have to stretch more to deliver these orders. So that's why you see there is a problem. There's a issue with the employee satisfaction. Even the delivery partners are not very happy about the whole thing. And that is probably the reason why this particular company is facing the problem that they have enumerated now. Okay, so does it make sense? Is everybody clear about this problem?
Yes, sir.
Yeah,
Yes.
yeah. So so obviously now the question comes, And we can see that this problem comes out very clearly when you try to visualize this data. And as I was mentioning, that this is the job of a business analyst. A business analyst essentially, or analytics essentially, talks about taking the data and making meaning out of it. So here we didn't do. It's also called descriptive analytics. It's not like we are trying to predict any customer churn or machine failure or anything like that. We are just trying to see a data and trying to make a meaning out of it. Okay, and that's the job of a business analyst. As you can understand, that this requires essentially your analytical mindset. Okay, your ability to find out or ask the right questions. Okay, and find out the reason for that. So now the question comes that what should Shweta do? Now suppose Shweta has understood this problem. What should she do? What is the action she should take?
She can push for the innovative pricing mechanism to weekdays rather than on weekends. So that offers and promotions should be applicable for a weekday sale, because people are anyway buying it. So, or no, sorry, in fact, it should be opposite. The promotions and other things should be pushed to weekends so that people start buying on weekends as well, and the demand normalizes rather than having a patchy demand.
Okay, so you're saying that I should have more, she should have more discounts in the weekends because she wants to push up the sale in the weekends. But there can be a counter argument saying that, look, people are already interested in buying on the weekdays. So if I give a little bit of discount in the weekdays, probably people will buy more from me. Why take the trouble of kind of pushing people to buy at a time when they don't intend to buy? Okay, so there are two views, right?
I would rather give a counter answer that I mean, in fact, during the weekends, people have more time to explore, and if we are giving more promotions and discounts and other schemes, maybe more advertising, those who are, I mean, not yet really those who are not aware of this product or maybe this product line, probably would be, I mean, interested in exploring further.
In the weekends, you're saying?
Yeah, in the weekend. Yeah.
Where do you think people are spending more time on this e-commerce store, on the weekdays or the weekend? Because unless they spend time, they will not be willing to explore, right?
Mostly weekends, sir. They have more time
But
to
if they are
spend.
spending more time in the weekends, why are they not buying on the weekend? See,
I'm
I
not sure of
buy.
this particular case study, sir, because this could be hypothetical as well. This
No,
could
it
be
is not
hypothetical.
hypothetical. No, it's not. By the way, the data is a real data.
Okay.
Okay, it's not a hypothetical case study. The
Or
data
maybe
is
the
a real
product which
data.
we are discussing is hypothetical, because this is
Yeah, the
more of a cosmetic
product is
sale.
hypothetical. Product
It
is
could be a
hypothetical.
consumable which is more used during the weekdays and not on the weekends. Probably weekends it could be of lesser use because people eat outside.
No, it's
So
not like a food product or something like that where it's so it's see there are two things here. First of all, it is a common pattern, and this is a pattern across all e-commerce, that the sale in the weekend is usually less compared to the sale during the weekdays. This is because in the weekend people usually go out. Even if you're talking about food delivery also, unless there is something like a, maybe a cricket match or something where people are staying back at home, usually people go out in the weekend for various purposes. They may be going out for some sports activity, they may be going out for watching a movie. And hence, when they want to buy, if they want to buy it from a physical store, they will buy it in the weekends, because in the weekend they will go out. In the weekdays, when they don't have time to go out, and that's when they need things, they will buy in the online. Okay, so this is a common trend across any e-commerce, that usually the purchase cycle is just the reverse of that of physical store. Okay. So that's one part of the story. So if I look at it, if I draw a graph, okay, it will be if I draw a graph of the demand cycle, which is in terms of number of orders, the graph will be like this. Okay. So it can be Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday. Like this. Okay, so graph will be like this. This is a typical graph of any e-commerce. Now, in order to understand this problem better, let me ask you a question. Okay, let's say there are two companies. One is company A like this. Okay, same, all other things being equal, and there is another company which is whose graph looks something like this. The blue line. If you are an investor, all other things being equal, if you're an investor, which company would you invest in, A or B? If you have given these two information.
A.
In other words, which company has a higher long-term potential? Okay, again, I'm not talking about day investment where you are buying in low and selling in high. Okay, that's not the purpose of this discussion. You assume that you're not a day trader, you are a long-term investor in a company. Where will you invest? Will you invest on A or will you invest on B?
A.
Why? You are a long-term investor, remember. You're not buying on Mondays and selling on, or buying on Sundays and selling on Wednesdays.
Although it is difficult to decide on the basis of just 2 weeks sale, but yeah,
Yeah.
I mean, we have a
I'm
larger.
saying, no. Assume that this is the pattern. Okay. While I've shown this for 2 weeks, assume that this is the pattern for a significantly long period of time. This is exactly the same pattern.
But there seems to be a variation in the sales, and there's always a chance of
Okay,
extending
first
this
of all,
variation even further.
okay. This one is, let me also specify that this is number of orders.
I think B is more better because in terms of since you can even forecast the data and then it is linear. As a long-term investor, I know that the company, even though it is not growing, but then I know for sure that the company is working well, as I see a linear growth there instead of a up and down graph growth for A.
Okay.
Sir, one thing what I can interpret from this data is, like, on weekdays, the inventory cost of company A will be high, and the cost for employees will be high on weekends. But in case of company B, we can say that the inventory cost will be normalized. The same will be consistent throughout the period.
Okay. Okay.
So I
Okay.
believe in company B, investing is must be better. And
Okay.
another point is, in company B case, they
Hmm.
must be doing something like, if they are selling some products on weekdays which are selling higher on weekdays, and some other products on weekends which are getting sold on weekends.
Okay. So you're saying that B is making an effort to kind of keep the curve flat.
Yes.
Okay. Okay.
Sir, are the product line comparable for the two companies?
Yeah. All are same. Okay. All are same. Everything else is same. Because that's the whole idea. Okay. Because that's the, if you look at the case, we are actually looking at A. Okay. So essentially our burgundy is A. Okay. Now let us look at these points one by one. Okay. Forecasting. Okay. Note that A is equally forecastable as B. It is not that A's demand is erratic. A's demand is consistent, except the fact there is a seasonality. There is a short-term weekly seasonality rather. Okay, whereas B doesn't demonstrate a weekly seasonality, but both are equally forecastable. Okay, if we have a forecasting model, both A and B demand can be forecasted. Growth. Note that since we are, remember when one of you said that is we need to look at the long term perspective. So I said that this is a pattern not just for 2 weeks, and that's why I didn't give any date. This is the pattern for every Mondays, every Tuesdays, every Wednesdays for a long period of time. So if you look at it, that the sale volume of A and B, which one is higher? I mean, pictorially, we're not kind of obviously not doing a mathematical calculation, but if you do a visual this thing visual analysis, whose sale will be higher, A or B?
On an average, they look same, sir. I mean,
In average, they look same, absolutely.
Yeah.
Because the sale, assuming that number of orders, all the orders have been serviced, and we'll come to that. Okay, so that's why I mentioned it's the orders and not exactly the sale, because if orders are not serviced, then it may not be sale. But assuming that all orders are serviced, then actually you see that both A and B, the area under the curve, which gives you the long-term sale volume, is almost same for A and B. So actually, we can't say that A is having a growth potential, that more growth potential B. We can't say that A's demand is difficult to forecast, whereas B's demand is easy to forecast. No, in both cases, they are same. So the difference doesn't lie over here. Now, let's look at this factor, cost. Now, if I say that every organization needs resources, and if I draw the resource line like this, and let me write it like this. And cost is a function of the resources. And these resources can be any type of resource. It can be human resources. It can be inventory. Okay, it can be machinery, any type of resource. Now, if for the time being, I'm assuming that this cost line is flat. Now, which company, A or which firm, A or B, will have a better financial result in the long run, and why?
B.
B. Why?
So as I mentioned that the cost, like if we bifurcate the cost and
Right.
in terms of suppose inventory cost and employee cost. So during weekdays in company A, the employee cost will be high, but at weekends the inventory cost will be high.
No. So here we're assuming that the cost base is constant. Okay, we are not assuming that the cost will be high or low. We are assuming that we are not varying the cost. We'll come to why we are not able to vary the cost. We are saying that the cost is almost fixed. Okay. So even if let's say there is variation internally between the different cost component, the total sum of cost is constant. So which company is expected to do better in such a scenario? Now we are not looking at only top line. From top line perspective, we said that both companies will be doing same, A and B, because the area under the curve is same, assuming orders equal to sale. All orders are service. Now, when you're bringing in the cost, we are also bringing the bottom line. From a bottom line perspective, which company is likely to do better? A or B, or they will do the same.
The cost is being kept on the same axis as the number of orders.
Sir,
Is that
Yes,
really?
yes. I mean, the axis can be different. I mean, the cost is the value axis. So I can assume, for example, the number of orders is for the time being equivalent to revenue. In that case, the y-axis will be in terms of currency, rupees.
In case of B, it will be a variable cost, and in case of B, it will be a static cost, and A, it will be variable cost.
Now, the cost is fixed. Cost for both A and B is the red line, which is same.
So, but the number of orders are changing, right?
Yeah, so what is going to happen? The cost is not going to become variable because the number of orders is changing. What will happen in this period? In this period of time. So ideally, in this, in a normal cycle, if all the orders were serviced, what will happen? There would be excess profit
Hmm.
in this time.
This
It will
cost is
make
towards the customers, right? And not the company.
the
It's
cost
not the
is for the
variable.
company. Cost is for the company.
company.
Cost is for the company. Okay. For the time being, I'm considering this to be a fixed cost. Okay.
Mhm.
So we'll come back to the variable and fixed later on. Okay. So assuming that all the cost of the company, the majority of the cost of the company is fixed, what is going to happen? There will be excess profit during this time. And there will be loss during this time. Correct?
Yeah.
Okay. So what is the difference between A and B? The difference between A and B is that A will have a cyclical profit and loss. Some days of the week it will make profit. Some days of the week it will make loss. The sum may add up to the same amount of profit as B is making. B is making profit on every day. Correct? Am I correct?
yes, sir.
Yeah.
So ideally, again, from a profit and loss perspective, both A and B should be same.
Yeah.
But then that is not the case. Why? Because now this is where the capacity comes in, the resources comes in. Okay, if the cost is fixed, okay, then what is going to happen is that during the peak period, you will have your capacity will be much less than the demand that you can service. As a result, what is going to happen? You will have under-serviced demand. Under-serviced demand means that some of the orders will not be able to deliver. Or there'll be other issues like customer dissatisfaction, which may lead to customer churn. And in the long run, your sale is going to go down. Sorry.
So these orders are the number which we have received and not the
Yes.
attended
That's why I
ones.
said that. Yeah, that's why it is say I said that this is not the sale. Okay, so in the longer run, what is going to happen? Your sale is going to go down because you're not able to retain, deliver some of the orders. Okay, and you are not able to satisfy some of the customers. So sale will go down. Okay, and what is going to happen over here? You are going to face what is called unabsorbed cost. So while during the peak period, you're not able to service some of your demand, in the lean period, you have excess resources whose cost is not getting absorbed in the demand or the orders that you are supplying. So in the long run, your profit is going to come down. In fact, your sale is also going to come down. A sale and profit is going to come down in the long run. Correct? Yeah. Makes sense?
Yeah. Yeah.
Yeah.
But then
So
there's another point to look at. During the peaks time, there would be some difference in terms of either the positioning or, I mean, the quality of product, or maybe the way it has been advertised. That's why
No,
the
no, 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 no,
peak
no.
demand
No,
is
we
being
are
seen for one company. Is that
no, no, no.
I mean, shall we look at that?
No, we are not, because then the cause we are mixing up the cause. We are assuming that the seasonality is purely due to customer demand. It is not created seasonality.
Okay.
Okay. Okay. So seasonality is purely due to customer demand. If the seasonality is created, then the whole problem statement changes.
Yeah, I was trying to look at why the customer demand is patchy and instead of being constant, just like the other product,
No,
because products are same.
that's as I said, that's the behavior of the customer. Okay, so the customer goes out in the weekdays, and hence the customer doesn't buy online, and the customer is at home in the weekends, weekdays, and customer buys online. In weekends they go out and they don't buy online. In case of physical stores, just the reverse. We have seen that. Okay, in restaurants that happen like that, in movie halls that happen. Every business has some seasonality. Can be weekly seasonality, monthly seasonality, etc. Okay, every business has some amount of seasonality, and that's given. Okay, we can't force the customers to come out in the weekdays. Okay, so that's the given thing. Now, if that is the given thing, now how so? So one way is that I accept this. I accept that there is a difference in this demand, and I try to manage my cost curve. So what should I do if I have to manipulate my cost curve? I have to manipulate it like this. I have to make my cost vary with my demand. Then A would be equally good as B. If I'm able to vary the cost curve with my demand curve, then A would be equally good as B, because A will also have this constant profit margin all the time. Correct? Am I correct? Yes or no?
Yes, sir.
Yeah.
Yeah.
The companies do that, and this is the whole idea of strategic cost management. If you have taken any course on strategic cost management, if you have studied subcontracting, what is the sole purpose of subcontracting? The sole purpose of subcontracting is to vary your cost as per your demand. If your demand increases, you are able to outsource that rather than incur fixed cost. Remember, outsourcing may not increase your long-term profitability. It is supposed to ensure that you are protecting the margin all the time, so that when your demand goes down, you're able to reduce your cost. When the demand goes up, you're able to increase your cost. That's the whole idea of strategic outsourcing. But the problem is that why this can work when the cycle is fairly long. Let's say it's an economic cycle where you have certain periods where there is a boom. Let's say every 3 years there's a boom in the automobile industry, and then the demand comes down. So many manufacturing processes of the automobile industry is outsourced, because moment it comes down, you are able to reduce your cost. But when it comes to a weekly seasonality, it's very difficult to manage through outsourcing. Why? Because if you, let's say, think of staff, restaurant staff. If you say that the key personnel in the restaurant are going to work only in the weekends and not work in the weekdays at all. Okay, so weekend is 2. So yes, you can ask them to work in the weekend and then take off on Wednesdays. But then if you say that you are going to give off on all 5 days and just make them work only 2 days, then that's the problem. Because these guys will say either you pay me for, if not all 5 days, pay me for 3 days. Okay, because I can't work anywhere else for those 5 days. Okay. Or you have to keep them for all 5 days. So same thing is, let's say with the delivery, last mile delivery, the delivery partner. If you ask the delivery partner, we'll engage, we need 100 motorbikes on middle of the week, and in the weekend I require only 10 motorbikes, they will say, well, no, what will I do with the 90 motorbikes? Or people who are delivering. So in a weekly seasonality kind of a scenario, it is very difficult to change your cost curve. So what is the option that you have? Option you have is, can you manipulate the demand curve? So try and get into a situation where B is. And this is called flattening the demand curve. You have to do certain things so that you encourage people, some people, not to buy during the peak period, but buy during the lean period. And all of us have experienced this kind of thing. Can you give an example where this kind of thing happens?
Sir, gaming parlors, they have high price on weekends, but less price in
Yeah,
weekdays.
yeah. Gaming parlors,
We
you
get
can,
discounts on
sorry.
food, I mean, food coupon or discounts on buffet meals during the weekdays, normally happy hours.
Happy hours, right? The best example is happy hours. The restaurants providing you happy hours from 6 p.m. to 8 p.m. So they are not only doing it for day, they are also doing it by hour.
Big Bazaar used to do that Wednesday Super Saver
Wednesday,
Day.
absolutely right. Because in physical store, the Wednesdays are the days where you have least sale. And in digital stores, e-commerce stores, you see just the reverse. Wednesdays are the days where you have peak sales.
When flight tickets of off-time flights like the 12 p.m. or
Off-time
1 a.m.
flights, yeah. This is called the red-eye flights. Okay, where you take a flight 2 a.m. in the morning, okay, from Mumbai to Delhi. So these flights typically will be cheaper. Okay. So yeah, absolutely. So everywhere you see in the industry doing this, essentially what are they doing? They are trying to encourage certain buyers. Now you can't encourage all of them because then they will leave you. There are some people who need to buy they will just buy in the peak period. But there will be some who have the option not to buy in the peak period and try and move them to the lean period. But you have to do that carefully, because one way of doing that is what is called surge pricing. So here you apply surge pricing. We see that Uber, Ola, etc. 9 a.m., 8 a.m. in the morning, the prices go up, and you have deep discounting over here. Big Bazaar Wednesday discount. So you have to price in such a way that it is just right for those people who can shift to a lean period. At the same time, retain those people who do not have a choice but to buy in the peak period. Because if you price it too high, then even some of the customers who are buying in the peak period, they will try to find alternatives, or when they may not buy at all because it's it's beyond their budget. Not all spendings are mandatory spending. There are discretionary spending. Okay, if I want to go out and eat, and if I find the price is too high, I may drop the idea of going out and eat at all, totally. So I have to do that very carefully. Now, how do I do that very carefully? That means this pricing has to be managed programmatically, and this is called dynamic pricing. All these companies, Uber, even the e-commerce, okay, Uber and all are more common. We see that every time. But even if you see a pricing of Amazon, Flipkart, etc., e-commerce companies, their prices are constantly changing. May not be changing as frequently as Uber, may not be on an hourly basis, but definitely on a daily basis. And obviously this price cannot be manually made. For example, let's say Uber price. It's not that somebody is sitting on a computer and changing the price. Okay, because the prices are changing too frequently and the right price has to be algorithmically calculated. Okay, so it has to be an optimization model, okay, through which it has to be calculated. Okay, and using that, the prices are fixed. So now you know the whole idea about this small caselet was the fact that once you see the data and try to interpret the data, you should be able to find out a solution based on the data that is given to you. This is an example of a data-driven mindset. Now, why are we talking today about data-driven mindset? Because classically what happened was that a lot of things were because there's not enough data, and even if there's data, there's not enough mechanisms to interpret the data, collate the data, aggregate the data, and interpret the data. We have to depend a lot on intuition or what is called a tacit knowledge of people. That can be a mechanic in the shop floor. Those of you who have been working in Maruti or other places, you know that this guy has been working for very long, and this guy is able to say that this machine is going to go down just listening to the sound, the vibration, and the sound that is causing. Nobody else has that uncanny ability. Okay, that's a tacit knowledge. Why is that tacit knowledge? Because it's not defined by physics. There is some relation somewhere with the sound and the breakdown, but you are not able to define it through a equation in physics. And that is why you have to depend on this guy. Similarly, if you look at an advertiser has uncanny knowledge that, okay, if this particular tagline is used, if you use this particular sentence, then people are going to really watch your ad. Now that is good and that is required even today. It's not that tacit knowledge is not required at all, it's still required, but this makes you dependent on few individuals and hence it's not scalable. You cannot have hundreds of people having that tacit knowledge. You're dependent on that person. If that person leaves, then obviously the knowledge goes away from the system. Secondly, it can also be wrong because things are changing. So somebody having a, in advertising world for last 20 years, people's tastes have changed and he or she may be still thinking that this is what people like. So today, because we have the data, we should validate any decision as far as possible with data. That is the data-driven mindset. So in organization, that is not very easy to find, especially in legacy organizations which are there for 50 years, 100 years. You will have people who still depend on their tacit knowledge, and they, in many cases, they're resistant to any data-driven mindset because they believe that they have the knowledge and there's no need for that data. Now, that's a very important mindset that needs to change because tacit knowledge can supplement the data-driven mindset. But the data-driven mindset has to come in the organization because tacit knowledge is not scalable and sustainable. Okay. Once you have this mindset, next time you take any decision, you will always ask the question, do I have the data to make a decision on this? Okay. So that mindset is very, very important. Yeah.
Yes.
Makes sense?
Yes, sir.
Yes, sir.
Great. 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 So I think that was the purpose of this particular small caselet. And now I will just take you to a little bit understanding of data science. And again, we'll not get into the mathematics of data science and all, but broadly, what it means and how is it different from what is called physics-based modeling or physics-based prediction. Okay. Any idea? I mean, how do you explain how is, let's say, machine learning different from a physics or a mathematics equation?
Please say the question again.
Yeah, I said that how is machine learning? So I can have a mathematical equation, right? I can just say that, you know, I can define an equation for velocity or acceleration, something like that. Okay, so there's an equation for that. Okay, how is it different from let's say a machine learning model?
Think in equations, mathematical equations,
Right.
you feed in the data, you get the output, you feed in the data, you get the output when the data is passed into the equation. But
Okay.
you'll not get any insights, or you'll not know the outcome of what exactly the data is doing at the end of the day. But in machine learning models, you feed in the data into the equation. You have your machine learning models which learn through the output of that particular equation,
Right.
and then you can get insights once you start feeding in more data. It's more of a closed loop feedback in machine learning model.
Right.
Well, in case of a mathematical equation, you get the absolute answer. In case of machine learning algorithm, you get an answer based on the historical data being fed and the way model has been prepared.
Okay, so that means you are not able to formulate an equation. So let's take a very simple example. What is the equation for Newton's first law? I was just Googling that. You have to go back to your physics class, right?
Force equals to mass into acceleration in that one.
Force equal to mass into acceleration, right? Force equal to mass into acceleration. Okay, so F equal to m into a. This is an equation, right? So that means if I know the acceleration or if I know the force, okay, and I know the mass, I will always know the acceleration. This is universally true. It cannot change. Okay. So that's machine based. Sorry, that's physics based. Okay, so there is no variation of that. But if I try to write an equation, weight of a person equal to something a into height plus something c constant. Is there any equation like that?
It's a straight line with a slope and some intercept.
No. This is a universal equation. I mean, straight line and slope is coming, after we can define these equations. Here we are able to define an equation, F equal to m into a. But can I define an equation like this? Is there any equation like this?
If there is a weight to height dependency, only in that case we should be able
There is
to.
a dependency. We know that there is a dependency.
Yeah, but
There's
based
a
on
weight to height dependency
collection
we
of
know,
several
but
data
can we?
sets, we'll be able to identify.
Yeah, no. So that means what we are saying, that we cannot define A and C specifically, unlike here.
Yeah.
Okay. Or let's say I think the other equation V equal to U plus AT. Okay.
Yeah.
The final velocity equal to initial velocity plus acceleration into time. Okay, this is a universal equation. Okay, but this is not a universal equation. We can't define this. There's no known equation like this. Correct? So here is the question of machine learning, where I am not able to build a physics or a mathematics based equation, which is universally giving the same output every time I give the same input. Instead, what I can have a lot of data. I can have millions of data where I have the height and I have the corresponding weight. There's no equation. Right now, there's no equation. We'll be trying to fit an equation. That's a different thing. But right now, these individual points are not following any equation. Correct? Am I correct?
Yeah.
Now,
Can
in
we
this,
say that the outcome would be a bit more normalized or maybe optimized in terms of response?
so now in this situation, unlike these situations where I know the input and I just apply the equation, I get the output. I cannot do it here like that, because every output is different. If this is the height, this can be the weight, this also can be the weight, this also can be the weight. Okay, so I have no one answer for a weight given a height. Correct? So what should I do? I will try to build a mathematical equation which is as close as possible to the actual answer, which means that I'll try to draw a line. And how do I know this is as close as possible? First of all, if I draw the line, then I'll be able to say if my height is this, if my height is h1, then the most plausible weight I'll have is this. It's not certain that I will have this weight. Unlike this case where it's certain that I know that if U is so much, A is so much, T is so much, this has to be the V. There is no other way. Otherwise, Newton's law will be proved wrong. But here I'm not certain my weight will be this much, but I am kind of, you can say 90% confident, certain amount of, I will be close to my actual weight. Correct? Am I correct? Yes or no?
Yeah.
Yeah. So this is not a model that is based on a mathematical equation. It is a model based on data on which I'm trying to fit a mathematical equation such that I'm closest to the actual answer. And how am I fitting that? I'm fitting that by ensuring that the sum of the squares of the distance between the actual point and the point that this equation is predicting, the distance is the minimum. The sum of the square distances is the minimum.
So we have done this in our quantitative methods subject.
Right.
Yeah, the
Right.
root mean square thing, right?
Right. Okay. But we need to understand why we need this and why. So
yeah.
So this is a very basic machine learning problem where I am trying to predict the height based on past data as opposed to a defined equation. Because I don't have any defined equation here. Correct? Now the next question is that how do I arrive at this line? Now, once I arrive at this line, I can now write an equation y equal to mx plus c. And I know that this will give me the most plausible value of weight given the height. But then how do I arrive at this equation? The only way to arrive at this equation is by trial and error. There is no other way. That means I start at any point. I have no idea. I start at any point. Let's say I start with this line. And I try to find out the square of the distances. I get a value. Then what is my objective? My objective is to minimize this is called root mean square error, RMSE. The technical term is probably this you have heard, root mean square error. That means I'm considering this to be the error. So this much I'm deviating from the actual value. Square that error and then find out the root. And I have to minimize that value. Why am I squaring that error and then finding out the root? Why not just adding them up? I could have just added the distances like length. Correct? Why I'm not just adding them up, the distances like this.
Sir, because one is in positive direction, the other one is in
One is
negative
a positive
direction.
direction, other is a negative. Yeah. So if I just add them up for any line, the sum of the errors will be 0. So I don't
So
know
we
which.
want all the data points to be closer to that average line, the trend line which we have selected. So probably the square will
Yes,
give us
yes.
the
So,
better.
but then I have to define that closer, right? I have to mathematically
Yeah,
define that
yeah.
closer.
Correct, correct.
If I just add up the errors, then it will always be 0. So any line will be the closest line.
Yeah.
Right. So that is not desirable. So you have to square it up so that any negative value turns positive, and then you have to make a root of that. So you bring back the square into one dimension. And then you try to see how do I minimize this root mean square? Is there any way to minimize this mathematically? No. Only way to trial and error. What is the trial and error? I will try to say, okay, fine. Let me try to move my line on the right hand side and recalculate the sum of squares. And then see whether it is increasing the error, increasing or decreasing. Now, even without doing a mathematical calculation, visually we can say that the error is increasing. Okay. So what we'll do, I'll not go this way. I'll go the other way. And here I'll try to draw the line. And here I'll see whether the error is reducing. And if the error is reducing this direction, I'll go further in this direction, further down in this direction till I come to a point where the error cannot be reduced any further. If I go this direction, the error will increase again. That is my line of best fit. Correct?
Yeah.
But while this is theoretically very good, practically there is a problem. The problem is that if I have to do it, of course, if I have to do it in real sense, I have to actually calculate. I cannot visually see this. Okay, I drew this blue line, but there can be another line which is slightly different, and this actually the root mean square error may be less in that case. So I cannot visually say which line is the best. I have to do this trial and error for every instance of this trial and error. I have to calculate the root mean square. Now, what is the problem of doing it? First problem is that it requires a lot of trial and error. So if you have to do it manually, then it takes a lot of effort. Second is that here I have only 2 dimensions where we are saying height is dependent on weight. Now, if there are multiple factors, let's say I'm predicting weight, and weight is a function of height, age, maybe sugar, maybe so many other factors. Weight is not just a function of height and height only. Weight is a function of many other factors. Then it is not possible to make this like a 2-dimensional picture. I have to write an equation which cannot be drawn in a 2-dimensional space. I have to write an equation like this: y equal to mn x1 plus m2 x2 plus m3 x3 plus mn xn plus c. And this equation has to be solved such that the root mean square error is the minimum for all these parameters x1, x2 to xn. Obviously, we require a computer for doing this. Machine learning is nothing but this. So note that machine learning is not some magic that has happened today. This is a very simple concept and statistics that was probably existing 100 years back. In fact, most concepts of machine learning, except probably these days, I mean, even if you look at Gen AI, generative AI, which is large language model, it is essentially based on probability distribution. It is nothing that a new theory has come. It is just that the old theory is now possible to be applied in real life because the computing power has increased. Now we can do this computation very fast. We can take n number of variables and do this computation very fast and do this computation real time. Data is coming from the machine, and immediately my model can say that whether this machine is going to break down, and immediately a reverse signal will go and signal an actuator that will stop the line. Or let's say when you are in the there's a banking website, a transaction comes, and immediately the algorithm is able to find out whether that is fraudulent or likely to be a fraudulent transaction or not, and immediately flag it off. And immediately a call will come to your phone saying that, did you do this transaction? If you have done the transaction, please press yes. Correct? There's nothing new. It's just that our computing power has increased, and this is now become feasible. The key difference is here we drew this equation, or we formulated this equation not based on any principle of physics like Newton's laws of motion. We made this equation based on past data. If the data changes, this equation also will change. In fact, that's called a data drift. And data may change. Okay, so this is not universally true. So far, fine.
Yes, sir.
Yes.
Yeah.
Can anybody tell me what this type of problem in machine learning is specifically called, where you are predicting a outcome based on certain attributes? An outcome is in terms of a specific number, like I'm predicting how much will be the weight based on certain attribute.
Regression.
Linear
This
regression.
is called regression. That's right. Very right. This is one of the first basic type of problem, which is called regression. And regression is one of what is called supervised machine learning. Why supervised machine learning model? Because you need to, how do find out this equation? You will find out this equation by giving a set of data and ask the model to draw this line. Then how do you know that this model is good at predicting any unknown data? Just because the model has been able to fit itself on an existing data set doesn't mean that the model will be able to predict any kind of data accurately. Given any unknown data where you don't know the weight, you expect the model to tell you the weight after getting trained. Now, the model that has been trained very well does not necessarily mean that the model will be able to predict any unknown data very well. For example, let's say if I do not keep any restriction to the fact that this line has to be linear, it may so happen that, which is a polynomial regression. So if you have a data like this, and if you tell the model that you do not have any restriction on the power, so if here there's the power of the equation is only 1. So I can have an equation which is y equal to m1 x1 plus m2 x1 squared plus m3 x1 cube, like that. mn xn plus c. I can have an equation like this as well. This is a polynomial equation. So suppose I do not give any restriction to the model that it has to be linear, then, and if we give the model this height and weight and data point like this, what do you think the model will do? And you ask the model that to get me a line that will minimize RMSE. How will the line look like? You have given the machine the freedom to create a line such that the RMSE is minimum and the model and the machine can try all sorts of permutation combination. What will be the line looking like?
So passing through all the data points.
Passing through all the data points, that's absolutely right. So the model will ultimately create a line which is like this.
Overfitting.
Those of you know data science, we call it over. Why is overfitting? Because this does not mean that if I ask the model to predict a particular value for this height, h1, actually the weight may lie somewhere here. For most of the people, this may be, but the model has got a data over here. And the model will predict that this is the weight rather than this weight, which is, or this weight rather than this weight, which is the most plausible weight, because that's what will happen in most of the cases. This, in technical term, is called overfitment. So what we need to do is we need to give another data to the model where I provide all this information, x1, x2, x3, etc. But I do not provide the information of y, whereas I have the information of y. I have this like an examination. So you are undergoing a course, and then I ask you to take a test. The questions in the test will be similar to what has been taught, but may not be exactly the same. It may not exactly be what I have discussed. So that's when you so many times say that, okay, the question is difficult or whatever. Okay. So that means what? That it is based on certain principles that have been discussed in class, but exactly that particular example of that particular problem has not been discussed in class. So real test would be that somebody who is able to relate to what has been discussed in class and solve that problem, even though that specific problem is not discussed in class. Okay. So a model will be able to behave like this. And that's what we call what we do in testing the model. That means you give the model a data where you have the answer, but you don't give the model the answer. You get the answer from the model and you then give marks to that model, how the model has scored. Okay. And that is the testing part of it. This is called supervised learning because this is you are training the model with a data set and then you are testing it and then you are making the model available to predict something which you don't know at all. That is why it is called a supervised learning. Okay. So far, fine, everybody?
Yes, sir.
Great.
Yes.
Now, if I take the problem a little differently and I say that, look, ideally I have these data points, height and weight. Same data points. Okay. Instead of just predicting the weight, I just want to predict whether somebody is lightweight or heavyweight. As it happens in case of, let's say, boxing. So I just want to classify that these
Logistics
group of,
regression, sir?
sorry?
Logistics regression.
Okay, but and I'm trying to explain the principle behind that. Okay, so previously I was giving a line which was giving me an absolute value of weight. Okay, it was giving me this is the height, this is the weight. If this is the height, is the weight. But I'm saying I don't need this. I just want to know whether a person should be classified as a heavyweight or classified as a lightweight. Now, this line will not be very useful because I do not know where I should draw this division, where I should divide. That beyond, above this is heavyweight, below this is lightweight. So instead, what I'm going to do is I'm going to twist this line a little bit. And I have to form an equation where the line, instead of looking like a straight line, looks like this. The prediction will be such that somewhere so here we are not actually predicting the actual weight. We are just classifying, saying that if the points are lying somewhere here, it will be classified in this class. And if the points lying somewhere here, this point or this point, it will be classified here. So I am classifying in two different segments. So I am transforming this line. So I have a line y equal to mx plus c. And I have to transform this line to a line like the blue one. So what is the function that I should use mathematically? The function is, if z is the line, so this is the y and the oops. This is the y and these are z. So how do I transform z from transform y into z? I change this equation to 1 plus e to the power minus y.
Sigmoid function.
This is called a sigmoid function. I have transformed a problem which is called a regression problem to something called a classification problem. So now I'm not interested in knowing the actual height, actual weight. I'm just interested to know whether somebody is a heavyweight or somebody is a lightweight. And this type of classification, this model of classifying is called a logistic regression. Whereas regression is a problem where you're trying to predict the actual value. In logistic regression, you are just trying to predict a classification. Okay, but it is based on a mathematical equation. However, I can also solve this classification problem without writing a mathematical equation, instead writing a logical condition. Instead of writing a mathematical equation, instead of that, if I write a logical condition, if height is more than this, then heavyweight. If height is less than this, then lightweight. This is also another type of machine learning model for classification. Does anybody, I'm sure people know the name of it because some of you seem to be aware of the machine learning techniques, but I just want you to figure out what would be that name, name of that machine learning model or method.
Decision tree.
Decision tree, absolutely right. Okay. So difference between a logistic regression and a decision tree, the logistic regression is an equation, whereas a decision tree is a if-else kind of condition. It's not an equation. Okay. For example, let's assume that I want to predict an app that will be used by a person based on the age of the person and the gender of the person. So let's say there are 3 apps. One app is Pokemon Go, another app is WhatsApp, third app is Snapchat. So I have a set of data that say if age is 17, gender is male, app is Pokemon Go. If age is 32, gender is female, the app is WhatsApp. If the age is 15, gender is female, it's Pokemon Go. If the age is 37, male, it's Snapchat. If the age is, let's say, 12, it's male, Pokemon Go. And if the age is, let's say, 40, is female, it's WhatsApp. Okay. So I have 6 set of data. Can you create an if-else kind of condition that will help me to predict whether a person is going to use Pokemon Go or WhatsApp or Snapchat?
So we can create a diagram saying if the person is less than 20,
Okay.
no matter
So,
what the gender is, the app is Pokemon Go.
okay.
And if the person is over, say 30, and if it is female, it is WhatsApp.
Okay. Okay.
And if it is male, it is Snapchat.
Okay. Yeah. So the data is pretty simple. So it's, you could probably just study the data and do that. But let's say it was not so easy. We had 2 options, either first divide by gender or divide by age. Let's say we divide by gender. Let's say I divide by gender. Okay. I have not, calculated mentally because not possible. Right now, you calculate mentally. Okay. So whatever you did was, calculate mentally, and you could do that because the data is small. But if you couldn't do that, then you have to take one of them and gender, and it's a male and female. If I say male, then what is going to happen? How many will be using Pokemon Go? 1. Pokemon Go equal to 2, right?
2.
WhatsApp,
0.
WhatsApp 0.
0. Snapchat,
1.
and it's female, Pokemon Go equal to
1.
1.
1. WhatsApp,
2.
2.
2. And Snapchat equal to 0.
0.
Now we can see that we are not, if we just divide by gender, okay, I am not confident with which app people will be using, because the outcome is impure. So if I put a box like this is not a uniform set of values. So this is called impure. If the outcome is impure, that means the entropy, the technical term is entropy, entropy will be high. Disorder. There's much more disorder in the system. It's not ordered. Right? On the other hand, if I have age, let's see what happens if I do it in age. Again, age, unlike gender, is not a categorical value. So I can divide age at any point. Less than 15, more than 15, less than 25, more than 25. But let's say, again, because the data is small, let's say intuitively, we say less than 20 and more than 20. Then what is going to happen? How many Pokemon Go?
Everyone, 3.
All 3. How many WhatsApp? 0. Snapchat? 0. Correct. Now what happens is more than 20. Pokemon Go is 0, but WhatsApp?
2.
2. And Snapchat?
1.
1. So I have achieved a pure state here. Entropy low. So this is exactly what you did. When you intuitively did it, this is exactly what you did. You stopped here. You said that. So mathematically means that I've reached a pure state. If the age is 20, I can say for certain that they will use Pokemon Go. But if the age is more than 20, I cannot say for certain there's impure state. So can I make it more pure? Now again, I'll use gender. I'll say male and female. Okay, and once I do that, I'll say if it's male, Pokemon Go is 0, WhatsApp is 0, and Snapchat equal to 1. And if female, Pokemon Go is 0, WhatsApp equal to 2, and Snapchat equal to 0. So now again, I've reached the pure state. So now, so this is the logic. So now, if I have to train a machine, what will I do? I'll tell them, and I remember that actually this data will not be so. So these data points from where on the basis on which I'm predicting this, these are called the features. And this is called the target. So usually I will have a large number of features and target and one target. And I'll tell the machine, try and iterate across multiple features and try to create a tree like this in such a way that you achieve the most optimum purity or the most minimal, not minimum, but minimal entropy. You figure out where to branch first and where to branch after that, so that minimal entropy is achieved. This is a decision tree. Okay. Now, why it is not minimum? Again, the same thing. If I allow the model to branch, the model will branch off in such a way that every bucket, which is essentially called a leaf, will consist of only one data point. And obviously, with only one data point, that's when the purity will be 100%. It will keep on branching till it reaches a point where every leaf node will have only one value. Which will lead to overfitment. Correct? So far, so good, everybody?
Yes, sir.
Great. Now, one important question. Both decision tree and logistic regression, these are two popular machine learning algorithms for classification purpose. There are more sophisticated ones like random forest, etc. We're not going there, but when should I use decision tree and when should I use logistic regression?
Sir, logistic regression can be used if you want to classify the data into two groups.
Okay. No,
But-
not really. Logistic regression I can use for multiple classification as well.
Or if you have only one feature.
When we have qualitative data,
So the difference is whether the attributes are qualitative or numerical. If you have numerical attribute, which one you should use, and if you have qualitative attribute, which one you should use.
so numerical, it is logistics, and if you have qualitative data, then you go for classification algorithm.
Absolutely right. Numeric is logistic because logistic regression is an equation. I cannot create an equation. I cannot create an equation for qualitative data. If there is a qualitative data, I have to convert that into a numeric data. That is called one-hot encoding. Again, I'm not getting into that. But by itself, I cannot use a qualitative data to create a mathematical equation. Logistic regression is a mathematical equation. On the other hand, decision tree is based on qualitative data. It can work on quantitative data as well, but usually, if it is only quantitative data, logistic regression will work better. Okay.
Yes, sir.
Great. So I think we'll close here. What I want you to do is, so next class we'll do a little bit of, have you, I mean, it seems that some of you, did you have any course on analytics in your program? Or some
Data
of you?
analytics, no, sir. No, sir. We
Okay,
had
so
only the quantitative methods only for the statistics and the.
Okay. Because some of you seem to know about classification. So is it from the course or is it from the quantitative
It was a
methods or?
separate course which we, yeah, it was another course which we did previously.
What?
Probably,
Some
I'm
of
not
you
sure of
did.
Makaran, but I did it. Yeah.
Okay. So, but not through BITS, right? It was some other independent course that
Not
you
this course, yeah. Not
Okay,
this
not
one.
this. Okay.
It was
So
different one.
what? Okay, so we will, just to get an idea and bring everybody on the same footing. We will do a very small hands-on exercise in the next class. But for that, you need to download a software. So this is a no-code software. So these days, even if you don't know coding, basic machine learning models you can build without writing any code. So I'll just give you the name of the software. So it's called KNIME, K-N-I-M-E. Okay, so this is KNIME, K-N-I-M-E, as you can see, KNIME. Okay, so you just go and download KNIME. So you just have to give your name, and this just for information purpose. You can give your name, email ID, etc. And there'll be a Windows installer there. So download the Windows installer, and KNIME will be downloaded in your desktop. And next class, we'll take a very simple example of how to build, let's say, a classification model on KNIME. Okay, so that it gives you an idea about how this machine learning works. Okay. So that's what we plan to do in the next session. Yeah.
Sir,
Okay,
not related to today's class, but
Yes.
what about the assignment which you were
Yeah.
telling me?
I'll brief you. I'll give you a brief about the assignment. Okay, that you need to do.
sir. Also the evaluation of the regular and the makeup exams.
Yeah, that will take a little time. Okay, so we'll do that. Okay, I'll do that.
Okay, sir.
So we
And
just got the papers.
are you planning to give us any quiz or it would be only assignment?
No.
Sir?
There'll be no quiz. There'll be no quiz.
Okay.
Okay, we'll have an assignment. In the course outline, I think there is 2 sections on quiz. So we will probably base it on some in-class activity that we can do. Okay, later on.
Okay, sure.
Thank you,
Because
sir.
assignment, if you can let us know.
Yeah,
The problem is a lot of assignments will turn up at end of the sem and will be
yeah.
overburdened. That
Yeah. Okay.
Yeah.
Sure.
and one
Okay,
more
fine.
suggestion.
Yeah.
Sorry, one more suggestion.
Yeah.
When the class is rescheduled, we usually don't get any notifications. If at all it is rescheduled, could you please release any
Yeah, normally
announcement?
I post it in the Teams. Okay, so this class also I had posted in the Teams.
Okay.
So, and I think the program office schedules it in the calendar. So,
Yeah. But yeah, if you release any announcement, then most of us would usually get it in our bit email ID. That's why I
So
was thinking.
yeah, normally
if
I
you
do
if you
it
create
in
an
the yes.
if you create an announcement in the Taxila portal, the email will be sent to everyone in that course.
This one also I've sent and put in the Takshila portal as well. Okay, so both this I think I would have done
Okay.
that. Okay, usually I do that, but again, I understand that. See, normally what happens is that the program office and all this, they take care of all of these things because it's usually difficult for me also to sometimes remember. Okay, where it is, but no. I think they do it by just rescheduling in the calendar. Okay, so I guess that's the way they operate. Yeah. So, but yes, I mean, I post it in Takshila usually. Okay. But do check your calendar, okay? Because that I think that is updated regularly.
Yeah, sure. Thank you.
Okay. Yeah.
Thank you, sir.
Okay. Okay. See you in the next class. Okay. Bye. Bye, everybody. Bye.
Thank you, sir.
Bye. Bye.